In this lecture, I want to discuss option types. Option types are kind of like lists, but it's a list that can have at most one thing. So, like lists, there's two constructors for option types. For lists, we have nil and cons. For option types, we have none and some. And the idea of an option type is to give us a principled way to deal with missing data. Often when we think about missing data, we think first of exceptions. And exceptions are sometimes a really great choice. Let's look at some code programming with exceptions. And this code is going to get a directory using a string. So given a string for a dir name, we're going to go to the file system and try and find a file with that name, and then get the list of files from that corresponding structure. Now, it's possible the file doesn't exist, and if that's true, then this list files will give us a null reference. In that case, we need to say we have an exceptional circumstance. Otherwise, what I'll do here is go to the list of all the elements in the folder and find those that are directories. So this will just filter out the elements in the list that are not directories. And this works just great on my system. So I have a Mac here, so I have a temp directory. And if I run this code, it'll find some of the files or the directories in my temp directory. But if I try a bad name, indeed I get an exception. And that's what I'm expecting because that's an exceptional circumstance. You're not supposed to call it with a bad file name. If you do this with option types, it doesn't look that different. You'll see here we have a return type that's changed from simply list of files to option of list. And then we have, instead of throwing an exception here on line 4, we return none. And finally, our return value, instead of being the raw list, there's a wrapper for the raw list called sum. So again, just contrasting with the previous solution, what have I changed? I've added option into the type and a sum wrapper into the result, and then we've replaced the exception with none. We can invoke this, and if I have the appropriate directory, it just works. And if I don't, what happens in this case is that I get none out. You'll note here that even in the case that I get something though, I don't just get a list, I get a wrapper around the list. So it's saying, yes, there was something and it's a list. Or, no, there's nothing with that name. Which one is preferable? It's largely a matter of taste, I suppose. If you don't expect a programmer to actually worry about the exception very much, then you're probably better off with exceptions because they're easier to ignore. On the other hand, if your programmer is really going to have to deal with the exceptions, then it can get cumbersome. So let's just think about the situation where a programmer wants to open up a directory called TEMP, expecting it to be on the hard drive. But then if it's not there, I want to open up a different directory called TMP. And if either of those work in that order, I'll take the results for this function. Otherwise, I need to somehow notify the user. What does that look like with exceptions? Well, I'm going to end up with something like this. So I'm creating a variable here for the result. I have a Boolean variable to say whether I found something. And here I'm going to go through the directories that I'm looking for as long as the found is false. And what I'm going to do is try to get the directories. And if that fails, then I'll throw a file not found exception and then return back to the next option around the loop. But if it succeeds, then found will become true and that will terminate my loop. Then once I have finished the loop, I can look at the found variable and see whether it's true or false. So if it's false, I didn't find anything. And if it's true, then I can actually just use the result. Here I'm using a match. You could also use an if then else. The key to this code is the mutability of the variable result and found. Without this kind of mutability, I can't write this kind of loop. The code is okay, but maybe not as nice as I'd like. With options, I can write something much more concise. So what I'll try is to get the directories from the temp, and if that succeeds, I'll take it. Otherwise, I'll get the directory from temp spelled differently. And then, after doing that, I will match on the result. If neither of those succeeded, then I'll print out there was no temporary. Otherwise, I will look for the result and print it out. This is quite powerful style of programming if you have complex code with possibility of failure. Option types are really, really useful for things on our local system that may fail, or for data that comes over the network once and may fail. For data that comes continuously at us, we'll use streams, which we'll talk about in a future lecture. Programming with streams and option types both are similar, and they use these functionals that we've already understood: map, fold, filter. Option types tell us that something is missing, and we've already seen a few ways of saying that in Scala. In fact, Scala has none, nil, and null, all of which are ways of saying that something that might have been there isn't. So none is the empty option. Nil is the empty list. Could have been a console. And null is the empty reference. It's a reference that hasn't been initialized. Note that the unit type is not an optional type. Unit doesn't have more than one possible value. Unit is always nothing. And the way we represent that nothing is using the unit value, or the open close parenthesis. You may have already noted that the use of nil in Scala mirrors the use of null in other languages like Java. We do a sort of case analysis on our lists to see whether they are nil or a console. And that's very similar to the kind of case analysis you do in Java to see whether an object reference is null or not. In Scala, the style of programming usually is to simply pretend that null doesn't really exist. It is there under the hood, but we often expect programmers to avoid null problems. And the style of programming in Scala often does avoid these problems. In recent languages, there's been a move to unify the concepts of option types and null. These are called nullable types. And two prominent examples are Swift and Kotlin. Swift used to program iOS, and Kotlin used to program Android. These languages include nullable and non-nullable types. In Kotlin, the none value is actually null. And instead of writing the option type, we write it as type with a query at the end. And in Kotlin, types that don't have a query at the end don't allow null. So what does this mean? Let's just look at some quick examples here. I have a variable a, which is a string variable initialized to ABC. If I try to assign null to a, the compiler will complain because string is not a type that accepts null. In addition, I can always invoke the function length on this reference because I know it's not possible for this reference to be null. Therefore, any method invocation on it is always safe. Instead, here's a nullable reference, b, which is given the type string query. And these kind of references are nullable, so I may assign null to that reference. The language is clever, however, because if I simply try to do a raw method invocation on a nullable reference, I will get a compiler error. The compiler error will tell me that this reference may be null, and therefore you cannot invoke a method directly on it. If you do want to invoke this method knowing that you might get a null pointer exception, the languages force you to put some sort of operator in there. In Kotlin, it's a double bang. So B double bang says, I know this is a bad thing. I could get in trouble, but I just want to do it anyway. So this says, trust me, I know this is not null, and we're going to be fine. We also have a safe call. So B query dot will check B for nullity. If B is null, it will simply evaluate to null. And if B is not null, then this expression will evaluate to the length. Safe calls are often combined with default values. So the query colon operator checks for nullity on the left. If the left-hand side is not null, then we simply get the value of the left-hand side. If the left-hand side is null, however, the right-hand side gives us a default value. Option types in Scala are very useful, particularly as error handling becomes more complex. They're also an example of a structured data type, like lists and tuples. And next week, we'll start to look at how to build our own structured data types.